Good evening, viewers. Today we are going to see about loudspeaker as microphone, as mic. So we all know that a loudspeaker converts electrical signal into sound waves. That is, electrical energy is converted into sound energy. So generally the symbol for speaker will be like this. Loudspeaker. You have two terminals. So this is a small loudspeaker. Usually the speaker resistance will be very low, 4 ohms, 6 ohms, 8 ohms, like that. So this speaker, the resistance is 6 ohms and it can withstand 5 watt of power. It is given here, 6 ohms with 5 watt. Now if you see here, you can see two terminals where we give the wire, these two wires, and this is connected to the voice coil. Inside that you will be having a soft iron core. This is a magnet. So what happens is, when you give electrical signal, so it will start oscillating. The inside there is coil that will oscillate in a soft iron core. So the coil is connected to the paper cone. This is paper. See, I think you can see these two. So this is connected here. Okay, this wire, it has torn up. But when signal is given, the coil will start oscillating according to the frequency and intensity of the wave. Therefore, since it is connected to the cone paper also vibrates. This is basically a paper. So this will produce sound waves. So that is loudspeaker action. Suppose if you don't have microphone, what you do is just connect these two wires. Basically this is a speaker. So these two wires, so I will draw the speaker now like this. Now you have this connected to an amplifier signal, and this is grounded. The amplifier amplifies, and once again you can connect another speaker. Okay. Now here we are using only loudspeaker, which is acting as a microphone. That means when you start speaking out or sing a song, the sound waves travels and it strikes the cone paper. So the paper will try to oscillate according to the sound waves. So when it tries to oscillate, inside there is a coil that will also oscillate. So when it oscillates, it will produce voltage, because we all know that when a conductor cuts a magnetic field, an EMF is induced in the conductor, or a magnetic field cuts a conductor, then also an EMF is induced in the coil or the conductor. So now what happens is, since we are transmitting sound waves, the sound waves vibrates this cone paper. The cone paper is connected to the coil. So the coil will start oscillating. Inside the coil, see, the coil will be like this. Inside the coil you will have a soft iron core. So there is a magnetic field. So therefore an voltage is induced. It tries to oscillate. So therefore a voltage is induced in the coil. That signal, that voltage is given here to the amplifier. It will be very weak signal that gets amplified and finally it goes to the speaker. If you are not still convinced with the results, or if it is going to be very very weak amplitude, you can try out this with an oscilloscope. Same thing, instead of an amplifier, what you can do is you can connect a oscilloscope, CRO. So in this position you can connect a CRO, cathode ray oscilloscope, in the lab. So you have a CRO. So you give it to the, and this is grounded, these 2 points. Now you can see the variations in the CRO. Okay, you can see variations in the CRO according to the sound signal. So this confirms that sound waves are converted into electrical energy. So therefore a speaker can be used as a microphone. Still it works correctly. Maybe the intensity of the signal in this case may be weak. The output of the speaker here will be, since we are using it as a microphone, here it will be very less compared to the normal microphone. But still, for emergency purpose, you can use speaker as a microphone. So that's all about this topic. Hope you have understood the core idea of speaker and microphone, and how we can use a loudspeaker, a speaker into a microphone. Thanks for watching. Nandri.